probably is a good description of what mutation testing is, but rather than operating on your infrastructure, it's operating on your code. Essentially, the objective of mutation testing is to figure out whether your tests are actually good at testing your code. Because you can see code coverage, but as I will present further, it is not always reliable. To kick things off, I want to see whether you are listening to Jess's talk. Who here can shout out some characteristics of a good test suite that you might have picked up from her talk or from your own experience? Throw them out. Good coverage. What else? Nice, you must have seen my slide. Anything else? Very good. All right, we've got about 3 there. I will, if I can get this to work. Okay, high coverage. That's what I used to think. And BDD descriptions, I'm a big fan of them. I always like in code review to pick people's BDD apart when they don't use given, when, then properly. And it should mock everything. And finally, it can be a bit boring sometimes watching tests run, so you should make sure that you use the Nyan Cat reporter. It makes it much more interesting. Fundamentally, though, I think even though those things are important, the most important thing is that a test suite should be able to catch regressions. If it can't do that, then it serves no value. You often have to spend quite a lot of time writing tests, so if they don't actually help you to prevent bugs, what's the point of them? And even though we might think that looking at coverage could be an effective way, as Jess talked about, it's not always completely reliable. I'm going to show you an example here. I've got some code here, very important code, and as such, I wrote some tests for it. Hit 100% coverage, which means we should be pretty sweet with that code. However, have a closer look at the tests I wrote. They definitely execute every branch of the code there. However, they're missing one crucial element. They don't have any assertions. They're completely useless. And yet, because Istanbul and LCOV figure out coverage purely based on whether a line of code has been executed or not, they can be fooled by situations like this where your code is being executed by the tests, but you're not actually checking whether the expected thing happens or not. That was a bit of a facetious example. I'm sure that that wouldn't really pass code review. But in a large project, it's easy to fall into a trap like this. Here's NVD3. It's an open source data visualization library, a wrapper around D3. The Istanbul report indicates that some of it has decent coverage. For example, scatter chart, you're looking at 84% statement coverage, which sounds pretty good. I mean, Pareto principle, 80% normally would catch most of the issues. So you'd think, based on that, that it should be pretty solid. But something about it doesn't feel right to me when I was looking through it. The implementation code is about 1,100 lines long, but the tests are only 230 lines. And I don't know about you, but I was always given the rule of thumb that the ratio between tests and implementation code is generally about 1 to 1, if not double the amount of test code that you have for implementation code. It felt a bit fishy to me, the idea that NVD3 could be getting close to, well, over 80% coverage with only a quarter of the code for the tests. And they're not doing anything fancy like snapshot tests, which could reduce the amount of time or code that they'd need for the tests. The other thing that made me feel a bit suspicious is that if tests are meant to stop regressions, why are there so many bug reports for scatter chart? I haven't checked recently, but it seems like they're building up. It doesn't seem like ScatterChart is able to maintain itself well and allow changes without regressions. Let's take on a different approach. Let's try mutation testing. Mutation testing, it's not a new idea. It's been around since the 1970s. It's otherwise known as debugging, fault seeding, or fault injection. was first mentioned in 1971. They did it with Fortran back in the day. It's a lot easier now than it was then. The basic idea is that you take your nice code and then you inject some chaos into it. You flip conditions around. In this case, we had some code which was very sensible. It only fired missiles when provoked, and now it is firing missiles indiscriminately. We probably wouldn't want that to happen, particularly if it was code that might be executed by a certain president of a certain country. Here's the kind of mutations that are possible. Things like changing a plus to a minus, a greater than to a less than, an equals to a not equals, or even completely deleting a function body. These kind of changes to code alter the logic quite radically, and therefore you'd expect that a decent test suite would be capable of picking up this deviation in logic and failing if it saw that. In mutation testing parlance, that is known as killing a mutant. If your tests fail after a mutant is introduced, that's good. You want to be able to pick up changes like that. If they pass, then it means they weren't very good at stopping potential regressions from entering. Here's what the output of Stryker, the main JavaScript mutation testing library, looks like. You get a HTML report, which looks a bit similar to the coverage report you might get from Karma or Jasmine. You see the areas in green where it seemed to do okay. There weren't any mutants that survived there. And then the bits in red, that's where a mutant was introduced and it survived. You can see here that one, number 371 in blue. I clicked on that one to reveal what the mutant was. In this case, it has changed a ternary expression there, which used to check that the top property was defined, and it's just changed it to true. You can see here that the test still passed in that situation, meaning that someone could probably go along and modify the code, break the API for everyone else, and you wouldn't get any indication. At the end of a mutation testing run, you get the mutant kill score, which is a bit like coverage, but potentially more robust. The idea is that you generate a whole heap of mutants. For scatterchart, for example, it generated about 500 mutants, and then it runs the tests against each set of mutants and tries to kill them. If it doesn't kill that mutant, then that mutant has survived, and you'll get the score at the end of how many you've killed. It's a very violent activity, but everyone hates mutants anyway. Let's actually get going and catch the mutants. We'll use Stryker, as I mentioned. I really like this framework. They're working on it actively. It supports not everything that I'd like. It doesn't have React support yet, but it does ES6, TypeScript, Babel, Webpack, Angular. For many projects, that'll do the job. When I ran it against NVD3, this is the score I got at the end. You will remember that the coverage score was 84%, but the mutant kill score was only 21%, which aligns with my personal intuition as to the quality of the tests. To explain this discrepancy, here's what the code for scatterchart looks like. As I mentioned, the code is about 1,000 lines long. 800 lines of that is one mega function. What has happened is the tests have executed that function, it's gone all the way through, and instantly 80%. It doesn't necessarily have any assertions in there, but because it's executed the mega function, which arguably is an anti-pattern when you're talking about writing code in general, that's the way they've written it, that's the result you get. You get misled by the coverage score. Mutation testing isn't so easily convinced as to the quality of the tests, but there is one downside to it. As Jess was showing with the testing pyramid, it can get quite expensive to run tests. And even if you're running unit tests, because you have so many different mutants that you have to try and kill, for example, with scatterchart, 500 mutants, it's having to execute the tests every time for every one of those mutants. If you have fast tests, that's not a big problem. I've got a little side project, tests run in about 500 milliseconds. That can easily cope with hundreds of mutants. But scatterchart, even though they're meant to be unit tests, they take 1 minute to run just for that one file, which is also ridiculous. I don't think they're really unit tests. They're more like integration tests combined with UI tests. For that reason, you do have to be discerning about when to use it. Because in some situations, if you have written good tests, then coverage can do just as well as mutation testing. There's been a bit of a battle-off between mutation testing and coverage analysis at GTAC, the Google Test Automation Conference, over the last couple of years. In 2015, there was a talk that propounded the benefits of mutation testing, making a compelling case based on all of the open source repositories that this researcher looked at. She found that in general, most of them didn't really have that high quality tests. Coverage was not a good proxy for mutant kill score. But in 2016, another researcher performed a slightly different analysis. He had a larger sample set, and he found that often there is quite a good correlation between coverage analysis and mutant kill score. For that reason, you probably want to have a hard look at your project and think about the consequences of an error. If you're working on a little side project, a little startup, don't even bother writing tests. It's probably not needed, because your key metric of quality in that case is not how fancy your tests are or whether you're using flow type or anything like that. The only thing that really matters is, do people want to use your app or not? If you haven't got any users, then forget about everything else. Forget about technical debt. Just get out there and sell more. But once you do have some users and people are paying money for it, then you probably should think about adding in tests to safeguard your app and make sure that it doesn't regress as it gets bigger. And as you start working on really high impact projects, if you're working on an implanted device, say a pacemaker, or if you were the engineers that built the Mars landing rover that actually crashed in the early 2000s due to a faulty calculation between metric and imperial conversion, you probably should be writing as many tests as possible and using mutation testing, because the consequences of failure could be lives lost or millions of dollars lost in revenue. I'm going to assume for the rest of the talk that you are or will one day work on a project like that, and I'm going to show you how you can use mutation testing to help you with that. Before we actually run some mutation testing, there's something that you need to do to get yourself into the mindset. Remember that you're killing mutants. The person who best can do that is William Stryker from the X-Men movies. To get into his mind frame, I'm going to put on a wig to make me look a bit more like him. I don't think it's quite the right color, but it'll do the job. Now that I've taken that step, I will configure Stryker. If you've ever used Karma, you'll find the config relatively similar. You specify which files you want to test, which files you want to mutate in this case, and you also set several other config parameters like the number of CPU cores to use. And then you hit go. It generates some mutants. This is running against my little side project, so it runs pretty quickly. It's found 8 files to mutate, generated 400 mutants. It's using 4 CPU cores, and now it's going. You can see the number that it's killed on the far left and the number that are surviving. I really wish they had a Nyan Cat reporter as well, because it's a bit slow, even though the tests run relatively quickly. Once it's done, you can open up the HTML report that I showed you earlier, and it'll show you in greater detail which mutants survived and which were killed. This can then help you to hone in on your tests and add more to backfill where you're missing tests. Just like what Jess was saying earlier, there are some things that you want to avoid when it comes to mutation testing. Who can remember some of the things that Jess suggested as best practices for unit tests and perhaps some things to avoid? Shout them out again. Okay, I'll have to help you. All right, number 1, slow tests. If you have slow tests, like NVD3, be prepared for 5 hours of your machine running on 4 CPU cores, meaning that you can't really do anything else during that time. It's good if it's winter time and you want to heat the room, but otherwise you probably don't want to work on a project like that. You do want to, before you even consider mutation testing, you'll want to improve the speed of your tests. The other thing that you absolutely don't want, again, I'm picking on NVD3, you don't want memory leaks. It turns out that whilst one run of the NVD3 test seems fine, when you run them 500 times in a row, it ends up using 4 gigabytes of heap. That's not really ideal. It's more than the default memory that Node is allocated. I had to bump it up, and I experienced major issues when I was trying to run it on CI, because I was running it on a T2 micro instance, which didn't actually have that much memory. So you probably don't want to have that. You also want to avoid dependent tests, because ideally, a good test runner is not going to run things exactly in sequence. If you have tests where one test relies on the result of the previous test, you're going to be in trouble, because ideally, that one at the top might be run on one core, and the one below might be run on another core, anything to speed it up. And finally, forget about 100% or 80%. None of that really matters at the end of the day. Quality is defined by many things. One of them might be the quality of the test, but you also need to factor in performance, accessibility, UI testing. There are so many other things to consider. This is just one tool in the toolkit that you should consider in certain projects. Things that you shouldn't avoid. Definitely go for the testing pyramid. The antithesis of that is the testing ice cream cone, where you have much more manual tests up the top than you have automated unit tests. That's probably the situation that NVD3 is in. It has basically, rather than unit tests, they're all essentially UI tests. And you probably don't want to try and mutate everything at once, particularly if you're doing it on CI. If you know that you've only changed one file, there's no value in mutating everything else. You want to get specific, otherwise you're going to be waiting for hours on end. And finally, I highly recommend that you get a Rhombi Cubo octahedro core machine. That will make your mutation testing run much faster. Also, don't do what NVD3 is. Don't have mega functions. Bad idea. All right. TL didn't listen. Coverage analysis can be misleading. If you create bugs, customers will hate you. And you've got to make sure that your tests run fast. Thank you very much. If you're interested in talking about it more, please come and talk to me. I'll even let you wear the wig if you want.